So this is homework 4, problem 1. And so we're given that a random continuous variable x is greater than or equal to 0, and that the expected value of x is equal to n. And given these two, we have to prove that the probability of x being greater than or equal to the square root of n is less than or equal to the square root of n. And so we know that the expected value of a continuous probability density function is equal to the integral from negative infinity to infinity of x times the density function f of x, small f of x. And so by putting in an initial condition where x is greater than or equal to 0, this integral becomes 0 to infinity of x, f of x. And since the bounds have shrunken, then that means this integral must be either smaller or at least equal to, or greatest equal to the previous integral. So we have this inequality here. And then let's say we have this integral going from the constant n, the square root of n, where n is positive. And so for any positive for integral from any positive value to infinity will still be smaller than 0 to infinity, because these bounds are smaller, and therefore the integral area under the integral will also be smaller. So this will be smaller than or equal to the previous function. And then finally, let's say x is equal to a constant. So let's say x is equal to the square root of n. Then since the x f of x is at least 1 degree higher than the square root of n f of x, so then this integral has to definitely be greater than or equal to this integral. These integrals will be equal if x equals the square root of n. But if x is a variable which will be greater than the square root of n, then this function will be higher than this function, the integral from the square root of n to infinity. And then going down here, since I'm out of space, so we can take out the square root of n from this equation, because this is in terms of x and not the square root of n. So we have the square root of n times the integral from the square root of n to infinity of f of x. Now what is this? This is simply just big F of x greater than or equal to the square root of x, because this is the integral of the density function of square root of n to infinity, which is equivalent of having the probability function from x greater than the square root of n. So this is times the square root of n. And now that we know that this, since the expected value is equal to n, and everything after this is less than the expected value, then this is also less than or equal to the expected value, this being n. So if we divide both sides by the square root of n, we get f of x is greater than or equal to square root of n, is less than or equal to n divided by the square root of n, which is equal to the square root of n. And therefore we proved it.